Hi guys, so today we're doing question 4, which is momentum type question. So more than welcome to pause the video and attempt the problems by yourself. Right, now let's get into the question statement. It states a soccer player kicks a ball of mass 0.45 kilogram to the east. Okay, now the ball travels horizontally at a velocity of 9 meters per second along a straight line, now without touching the ground, and enters a container lying at rest on its side. The mass of the container is 0.2 kilograms, right? Okay, so the ball is stuck in the container after the collision. Now the ball and the container now move together along a straight line towards the east. Now the axis to ignore friction and rotational effects. Alright, now for 4.1, it's a definition. Like I always say, I will never write the definition here, I will only state it. And the definition of the principle of conservation of linear momentum in words is what? It's the total momentum in an isolated system remains constant. That's the definition. I repeat, the total momentum in an isolated system remains conserved or the same. Right, now let's come to 4.2. Calculate the magnitude of the velocity of the ball container system immediately after the collision. So they want us to find the velocity of the ball and the container after they collide, right? So like I always say, if the examiner asks you for the definition of something before, you are going to apply it in the next question. Here's what we're going to apply. It's the momentum before is equals to momentum after or final. So it's going to be, let's call the ball A. Yeah, let's call the ball A, the container B, right? So the mass A, V initial plus mass B, V initial is equals to it's equals to what? It's equals to V F mass A mass B. Okay, now after we've done this, we can now fill in the masses. Now we know that the mass of the ball is 0.45. What was its velocity? Its velocity was what? It was 9. And the mass of B, it was 0.20, and it was stationary at rest. Now the V final is what we are looking for, and the masses together, what are they? The sum of both of the masses, it's going to be 0.45 plus 0.2, which is 0.65, right? So 0.65 divided, or just take that 0.5 and divide this by the 0.5. So you should get, your answer should be 6.23. 6.23 meters per second. Alright, now let's come to 4.3, right? Determine by means of suitable calculation whether the collision between the ball and the container is elastic or inelastic. Now, how can you prove it? So, in order to see if it's elastic, you have to check the kinetic energy. If the kinetic energy is the same, the kinetic before and after is the same, it is elastic. But if it's not the same, it's inelastic, right? So, for us, how we're going to do it is by using the kinetic energy. Like I'll see, v squared. So between the ball, between the ball. Okay, so let's start with the ball, which is 1 over 2, 0.45, and the v squared, which is 9. This is initial, right? Just to be clear, and you should get 18.225 joules, right? Now the EK final is squared. Remember, both of the both of the containers, or both of the masses are combined. Why? Because it was a system, right? So 0.45 plus 0.20, and then V, it's the one that we calculated, and your EK should be what? 12.614 joules. Therefore, EK initial is not equal to EK final. Therefore, it is what? It is inelastic. Therefore, the collision is what? Is inelastic. Yeah. Right. So we've reached the end of this video, and if you have any questions, please do let me know. I'll leave a message below, a comment, and you're more than welcome to email me if you want to inquire. Well, guys, I'll see you in the next one.